So we're going to talk about lab number 1, metric system and measurements. In the metric system is used for scientific measurements. It is based on so-called decimal relationships, which makes calculations and conversions from unit to unit easy. You need to learn the names of a few units in the metric system, and you can create units of the larger and smaller sizes by adding a prefix to the basic unit. This is the table of prefixes used in the metric system. Kilo is 1,000 of a basic unit, hecto is 100, deca is 10. Deci is 1/10 of the basic unit, centi is 100th, and milli is 1,000th of the basic unit. Here's some illustration. So 1 liter is 1,000 milliliters, and 1 milliliter is 1,000th part of a liter. 1 kiloliter is 1,000 liters. The mnemonic rule to use to memorize those prefixes is shown here. So how do you convert from one unit to another? So you write down the prefixes, and then you move from the unit that you need to convert from to the unit you need to convert to. You determine the direction and the number of spaces. So for instance, you need to go from 12 grams to milligrams. So gram is the basic unit, and you go 3 steps, 1, 2, 3, from grams to milligrams. So you go into the right direction and you add 3 zeros. You move the decimal point 3 spaces to the right. So the answer is 12 grams are equivalent to 12,000 milligrams. What if you want to convert 340.5 centimeters into hectometers? So you need to go from centi to hecto, taking 4 steps to the left. So you need to move this decimal point here 4 spots to the left. So that will be 1, 2, 3, and 1 more, which is going to be 0. So end up with 0.03405 hectometers. You will need to convert these units by yourself in order for the lab to count for the submission. And now we're going to move on to obtaining some data for your lab. So first, we're going to measure the length of the test tube in inches. So here you can see the bottom one is in inches, and it is up to you to take the measurement using the image, the video here. And then you need to measure the length of the same test tube in centimeters. Okay? Now consider the fact that 1 inch is equal to 2.54 centimeters. So you need to multiply the measurement in inches by 2.54 and see if this calculation agrees with the measured length in centimeters, and your answer will go here. Now here's the length of the page in centimeters. Okay, so we're going to measure the length. So it's actually millimeters, but like 27. So 270 corresponds to 27 centimeters. So measure the length in centimeters, and then the width of the page. 210 is equivalent to 21 centimeter. So you need to convert, so that's your measurement. You will need to convert those measurements in the meters or millimeters. Next exercise is dealing with measuring volume. Volume is measured using graduated cylinders, and you always measure by the bottom of the meniscus. So you will have to measure the volume in the graduated cylinder, and you will see it in a second. I'm going to flip the image. So here's the graduated cylinder. You need to take the measurement, how much water is in there, and write it down in the milliliters. The graduated cylinder, all measurements here are in milliliters. So whatever the measurement, please write it down. 1 milliliter equals 1 cubic centimeter. So you need to write down how many cubic centimeters your cylinder reads. Now next we're going to measure the total volume of water in an Erlenmeyer flask. So we're going to fill the flask. We're not going to fill it to the top. This is how much I poured there. And then we're going to go and pour the water into the graduated cylinder in several steps. So we're going to pour it until 15, okay, and then so on and so forth. So let's try and do this. So here's the graduated cylinder, here's the Erlenmeyer flask, and I'm going to fill the Erlenmeyer, the cylinder. With that amount of water. That's the first installment, that's the first volume. So I pour it out and I do the second installment. So that is the second measurement from the flask, and whatever I have left will be the third. By adding these 3 volumes, you'll be able to measure how much water I had, how many milliliters I had in my Erlenmeyer flask. So please write down this answer in milliliters and this square, and then how many cubic centimeters. And we're not going to be using a 10 milliliter, measuring the number of drops in 1 milliliter. Next we're going to measure the weight. Now here's the deal. The problem is I don't have any coins with me, so we're going to use some other objects to sort of equivocate them with the coins. So you can see the scales, and the first object to measure in the scales, which will be equivalent of a penny, will be this ruler. So that's the weight of the ruler. You can correct penny for the ruler. The second object will be this pencil. This pencil right here. So that's going to be the mass of the pencil. And the third object that we're going to measure will be the pipette. So this is the mass of the pipette. Next, we're going to do some readings here. So we're going to start with the weight of the beaker, and then we're going to zero it out, and then we're going to place the pipette into the beaker and check the weight of the pipette. And you will have to compare the weight of the pipette from the previous experiment to the weight of the pipette in this one. So I'm going to place the beaker first. Need to tear it. So I'm placing the beaker, and you can see this is the weight of a beaker. You can see the decimal point right after 50. And I'm going to tear it. So now I zeroed out measurement, and I'm going to put pipette into the beaker. So you need to compare the weight of the pipette that's measured here to the weight of the pipette that was measured in the previous experiment. Now what we're going to do, we're going to place both beaker and the pipette on the scale. So why do we do it? Now, by looking at the measurements, you measured the weight of the beaker, you measured the weight of the pipette, you measured the weight of the pipette when the beaker was on the scales but zeroed out. So now add the weight of the beaker, add of the pipette, and the total weight of 2 that we just recorded, and answer the question if the weights are additive. The weights may not fully match in the final digit because of the slight inaccuracy on the last measured number. This is why significant figures are important in calculations.